Hello, this is going to be a simple skill that you'll need to use to start to solve more complex spectral problems. And it's just calculating the degrees of unsaturation. It's one of the D-level learning outcomes for Chem 363. And all we're going to do, it's going to tell us, we're going to do a simple calculation. It'll tell us whether or not the molecule contains double or triple bonds or rings. So what happens if you look at a structure like hexane that has C6H14, because the formula is always N for the number of carbons and then 2N plus 2 for the number of hydrogens. So if this is 6, this is 2 times 6 is 12 plus 2 is 14. But you'll notice as soon as I make it a cyclohexane, I'm at C6H12. Or if I make it a hexene, I'm at C6H12. So what we're going to do is go backwards, given a molecular formula. Can I tell if there are any double bonds or rings in the structure? And the formula is the number of hydrogens that you would expect. So if we do this one backwards, if I saw this, if I have, well, let's just do it different. Well, we'll just number of, yes, if we look at the number of hydrogens on the saturated system, if I had this formula C6H12, I would look for the number of hydrogens on the saturated system, which should be 14, the 2N plus 2, but I actually have 12, so that's the observed. So 14 minus 12 is 2 divided by 2, and I would get that I have one ring or double bond in the structure. There's a couple of caveats here. If you have an oxygen, you ignore it. If you have a halide, you treat it as a hydrogen. If you have a nitrogen, you treat it as if it's another carbon hydrogen. So let's do a few of them. So if I have C5H12O, the number of expected hydrogens would be 2 times 5 plus 2. So that would be 12 minus 12. And so I don't have any sites of unsaturation. So this is going to be 0. You can divide it by 2, but 0 divided by 2 is 0. C5H10, so I'm going to do the same thing. 12 minus 10 divided by 2, and I get 1 site of unsaturation. Benzoic acid, now I've got C7H6O2. And so that should be 16. So that's 7 times 2 plus 2. So 16 minus 6 divided by 2. 16 minus 6 is 10, divided by 2 is 5. And boy, that seems like a lot for a small little compound. But let's just take a quick look at benzoic acid. And in fact, I have 1, 2, 3, 4 double bonds and 1 ring. So every time you have an aromatic ring, that's 4 sites of unsaturation or degrees of unsaturation. You can call it SU or DU. Either one, you see them used the same a lot. So let's try caffeine. That's C5H11N. So remember, we have to, for nitrogen, treat it as a CH. So we're going to calculate this as if it was C6H12. So then 6 times 2 is 12, plus 2 is 14. Something's wrong here. Minus 12, there's more than, gotta go look this up, that's not C5. So we'll calculate this. This is 1, but that is not the formula for caffeine. And go back and do caffeine. So then you get something giant. So let's try this. I've got 5 nitrogens. So that means I'm going to convert my formula to C25 because I've got to add 5 carbons and 5 hydrogens. So this, C5, I'm flustered now. C30H30 because I added 5 hydrogens and 5 carbons and I ignored the oxygens. So this would be 30 times 2 is 60 plus 2, 62 minus 30. And divided by 2, so that would be 32 divided by 2, and I get 16. Now I'm just, so these are pretty straightforward. do 3 or 4 or 5, and then you'll get one of your learning outcomes for demonstrating that you can do this repeatedly. And it'll be on almost every PSA. So you'll be able to have lots of opportunities to show me that you know this.